Hello, everyone, and welcome to the AI for Educators campaign being organized by SWAYAM Plus in collaboration with Intel India. Please note that this is a campaign for all educators, regardless of the subject they teach, the institution they come from, or the geographic location they belong to. Hope you all enjoyed the seventh session, AI for Outreach and Engagement. Also, hope that you have attempted the self assessment quiz. One must attempt a minimum of three or more quizzes to be eligible for a certificate. Today, we have the eighth session lined up for you. Today's session focuses on explainable AI. It aims to help participants understand the growing need for transparency in AI decision making. This session introduces explainable AI, its need, principles, and applications across domains like healthcare, autonomous driving, and surveillance. The session is being conducted by Dr. Ashwati, an Intel certified AI coach. Dr. Ashwati Ravikumar is a certified Intel AI for Youth and AI for Future workforce coach. She is a senior AI ML consultant with a PhD in deep learning, a postgraduate diploma in cloud computing, and a domain certification in data science. Actively engaged in training and skilling students and professionals, and excels in developing curricula for evolving technologies and delivering technical training to diverse global audiences. And now I hand over to Dr. Ashwati.
Good evening. A warm welcome to the AI for Educators Padaika Future Campaign 2025. So, this campaign is aimed at empowering educators with the latest developments and skills in artificial intelligence. So, educators from diverse academic streams, irrespective of their subjects, they can join this campaign. And in today's session, we are going to discuss about explainable AI. So this session is actually to help you understand like why transparency and interpretability is really important when we work with AI and build AI solutions. So here in this session, we will walk through what is explainable AI, what is the need for having explainable AI, what are the principles and how this can be applied to critical domains like healthcare, autonomous driving and surveillance. So few methods like SHAP and GradCam will also be demonstrated in this session to show like how transparency can improve the trustworthiness of a particular solution. So this is the overview of the agenda. Like I mentioned, we'll first see what is the term explainable AI is about. Then why do we need explainable AI? What are the principles of explainable AI? Then we'll go to actually what is the applications of explainable AI in computer vision. What are the challenges, best practices, and how explainable AI can be achieved. So before we begin to explainable AI is something which can help us solve real world problems. So this real world problems can be with respect to healthcare sector, transportation sector, finance, and also even climate related problems. So AI will help us the accuracy to increase the accuracy of prediction and also decision making. So, as time grows, AI models are also growing complex and their logic is becoming more and more difficult. So, as users usually do, like provide input and get output. So, they are not trying to understand how this output is achieved or what is the reasoning that is happening in between. So, that is where the transparency aspect is lacking. So this will actually reduce the trust in these AI models and also the accountability aspect. So this whole AI model is acting like a black box. So it is just providing you outputs without even telling us like how it arrived at these results. So the internal working is actually very important and how AI actually came to this decision. Based on what features, what feature importance it actually took this decision. So the lack of explainability is something which can actually affect the trust. It can cause problems with accountability. And also when we are taking decisions, it is actually very important to have an explainable AI solution. Say for critical fields like medicine or transportation sector or law, it is actually very important to understand why that decision was taken. Say when a doctor give a diagnosis, he cannot just give it randomly. He actually take the help of data points to come to that conclusion. Similarly, explainable AI is actually to tell you like how it AI model arrived at this solution. So, very critical applications like healthcare and transportation need actually explainable AI solution. So now we actually have like AI tools which can help us predict diseases, analyze medical scans, and it will give us a result. But when it is able to give us a reasoning why it came to this particular conclusion, these models are becoming more trustworthy. See, let's take an example. We have an AI model which will analyze our patient data. So it can be some medical values or MRI scans or medical history, and it is actually going to diagnose whether a person have like diabetes or not. See, AI can predict whether he falls in the high risk category or the middle or the low risk category. But how is it coming to that particular prediction? How is it able to give us that prediction based on what data points it told us that the person is in the high risk category? So this actually will help you to better understand and also better trust these solutions that are given. So when an AI cannot explain, it actually slow down the adoption of these solutions. Users are not able to relate to these models. They are not able to understand how it came to this particular decision. They were not sure like whether it's a wrong clinical decision or it's a good suggestion. So it is actually very important and that if we have an explainable AI solution, it is able to bridge that gap and it is able to actually help you get a better understanding. It will be able to answer you the question why. Why did it predict like this? Or why did it come to this particular decision making? That is something which is very important about explainable AI. So now let's look at explainable AI as something which is going to help us open this black box. So if AI is like a black box, that was you are giving an input and you are getting an output without understanding the inner working, explainable AI will help us open this black box. It will contains tools, processes that will help you understand like how AI came to this decision, how AI is able to give you this particular suggestion. Say when a doctor is actually using a tool to give you like a recommendation, he is actually going through the data points, he is looking at all the measure blood values, all these features, and then actually providing like a suggestion like medication or things. But with XAI, it will actually tell you like why it categorized a person. So it can be because of the high blood sugar levels, or it can be due to lifestyle data. It will clearly give like proper justification how it arrived at that particular decision. So when it does that, the confidence in trusting is actually more. So you are more able to trust it and the transparency aspect is getting better. So you are able to understand like how it came to a conclusion. So it is very transparent that how AI works and how AI is giving us this particular suggestion. See, when we talk about real world scenarios, this transparency aspect is very important for these real world use cases. So, XAI actually helps us to follow with the ethical compliances. So, whenever a decision is taken using an AI tool or an AI model, XAI will make the decision more accountable and also easy for humans to understand. So, if we try to put it in very simple terms, it is actually how we can understand what is the reasoning of AI. So, the reasoning of AI can be made understandable to a human, or how it can be explained to a human, and what is the logic behind this particular engine or this particular algorithm. That is what XAI actually provides. It will very clearly tell you, like, on based on what logic, what reasoning this particular model arrived at this particular conclusion. So now explainable AI is where what we are actually discussing. Now we also need to understand why. Why is this very important? Say, when we are working with advanced AI models like deep neural networks, convolutional neural networks, they are actually complex models and they will actually work and come up with the prediction. So to make it clear like how they came to this prediction, we need XAI models and we need these toolkits which can help us to understand. Say you are trying to understand like what are the steps that AI is taking, or what are the tools, or what are the basic understandings AI is making to come to this output. We can have like few explainable AI frameworks and tools. So these tools will actually look inside these models. They will understand like which features or which data point is actually getting that influence on the prediction. Say let's take an example. We are trying to see like a loan approval process, a AI solution which is going to like give a suggestion whether a person should be granted a loan or not based on his different data points. So this data points can be like his income, his credit score, his age, his profession, his balance. So there'll be like so many data points based on which this particular AI project is going to give like a prediction whether a person should be granted loan or not. So here, when XAI comes into picture, it will tell you based on what feature it took this decision. Was the credit score given more importance, or was the loan denied because of a lower credit score, or was it because of a lower balance, or based on the income level? All that level of understanding can actually be provided using an explainable AI toolkit. So there are like so many different frameworks which helps in this. So some of the most commonly used frameworks are SHAP, shapely additive explanations. So it will tell you like how is the features contributing to the output. Or it can be like a line, local interpretable model agnostic explanations. So it will show like what are the effect of features and on the outcome. So it will build simple local models around each prediction, and using that local models, it will show how each feature is getting the effect on the outcome. Then there are also like a PyTorch libraries like Captum, which can actually help us visualize which parts of the image or text is influencing a model's output. So if we put it very simply, explainable AI is a bridging the gap between a human's understanding and AI's complexity. So now humans are able to understand the logic behind this reasoning, and they are also able to understand like what reason they had to take this particular decision. So now let's try to see it with an example here. So here in this particular image, you can see like two parts. The above part is without explainable AI, and the lower part of the picture shows like with explainable AI. So if we look at the above part, we know that the learning process happens and we actually get an output. But we don't have answers to why did it come to this decision and why not another decision. Why did it fail and why should I trust it? So there'll be like so many questions that are unanswered. So many questions which is like a black box, and without any explanation it is giving an output that this is a cat. But if you look at the bottom part with XAI, you can see that there is a proper reasoning. It has fur, it has whiskers, it has claws, and all these features helped us understand that this is a cat. So we are getting answers to all those questions which were there before without XAI. So when we were trying to look at this example, without XAI, we had a lot of questions. But when we bring XAI into the picture, it is actually giving us answers to all these questions and improving that transition. So, like, it is going to improve the trust and also the transparency of these AI systems. Now we have understood the basics of explainable AI. Now let's look at like why, what is the need for explainable AI? Why is it so important when it comes to real world applications? Say, for example, to demonstrate accuracy. AI can be actually used to come up with accurate predictions. But unless the users are able to validate the predictions are correct, they will not trust it. So that is where that validation comes into picture. Explainable AI will give you that validation whether a prediction is correct or not. Say, for example, we have a system which is helping to predict a patient's condition. Say, based on the cholesterol levels or ECG levels, it is going to predict like a heart condition. So, there are systems, AI models, which help in that. When explainability is added to it, it will give like a clear reasoning like why it gave a suggestion. So there it is able to actually make it more relatable to the people who are using these models. Explainable AI will also help you prevent errors. Say, if the errors are happening due to wrong data, missing features, or unexpected situations, XAI will help you detect these errors easily. Say, when a particular input leads to a wrong prediction, actually xai can help be xai can actually act like a debugging tool which will help you trace the error and which actually lead to that particular fault. So XAIs at times can also act like a debugging tool for AI to trace back the error, where did the error come from, and what is this particular error about. So all that is something that is related to XAI's need. So it can help us get a better accuracy. It can help us to prevent also errors. And the same time, it helps to reduce the bias. So bias is when we have like a data can be biased. Data can be favoring one community or one sector or a particular kind of data alone. So when we have XAI, it will very clearly show that if there is a bias in the data. So this will ensure that your data or your model is fair and it is actually coming up with more ethical solutions. So when we work with these kind of critical applications, healthcare, finance, education, it is really important to have a solution which is fair and ethical at the same time. We want to have a solution which is both fair and ethical. So, in addition to the benefits we have listed, it also helps to improve the models. Say, explainability helps you to understand how a feature is contributing to your prediction. So, when you get these kind of understanding, you can actually refine your models, you can optimize your models, you can work with them over time to increase the accuracy. Say, if you are, for example, working on an agriculture project, say a crop disease detection. When we use XAI, we can actually understand like whether we should, whether our data is more focused on the leaves or whether the data is more focused on the soil color. So all these kind of understanding the feature significance can actually be given through an explainable AI. So it is more or less acting like a part or a helper to this AI model, which will help you to make your model more strong and more better. So XAI will help you to improve your models over time, and it actually ensures compliances. When we work with finance, healthcare, transportation, there needs to be a need for both fair and transparent data and transparent decision making. So actually XAI will help you to ensure all these ethical principles are followed, and it will provide a new insight. So, when we are using XAI, it can also help us to discover patterns, discover the hidden knowledge in the data. So, what is like a hidden factor, or what is that factor that is contributing to this particular disease, or why is this particular symptom that is occurring? So, all this will actually be done using explainable AI. So explainable AI on an whole is contributing to your AI models, not just in making it trustworthy, but also increasing the accuracy, making you better models, understanding the feature significance, and following the compliances, and also giving you new insights. So now let's see like what are the principles of XAI. So when we look at XAI, the basic principles can be like explanations. The system will give you reasoning. The system will give you like evidences, reasons, and explanations why this particular output. Meaningful. The system provides you like explanations that are understandable, how a normal audience or how a person can relate to this particular output. It will give like very simple explanations on how it came to this particular output, and it can also explain the accuracy, why this accuracy, why you should actually trust this accuracy, what led to this increase in accuracy. So when we have an explainable AI model, it will give like a proper explanation, and this explanation can be about accuracy and also like very meaningful and in simple terms. And finally, knowledge limits. The system operates within this condition specified, and it will actually tell about these outputs that are produced. It is not going to hallucinate and come up with answers. It will actually work within the specified conditions. So these are the main principles of explainable AI. Now let's try to understand it with an example. So when we look at the computer vision, healthcare is one of the most impactful domains where XAI is needed. Say, for example, Google's DeepMind. So this actually is used to analyze the retinal scans and detect like diabetic retinopathy and also macular degeneration. So when XAI is there, it is actually able to highlight the affected regions of when it has a retinal image, it will be able to highlight the affected regions and also give an explanation to the doctor, and this explanation is a visual explanation. So this makes it easier to actually understand why it came to this output. So it's more or less like not just a diagnosis, but also like giving you the correct areas of concern, which is the correct area which is facing a problem, which is the point that is contributing to this particular disease. So that kind of analysis is also something we can get from a XAI solution added to these kind of products. See, then we have the Path AI. Path AI is a cancer detection in tissue samples. So Path AI also have explainable deep learning to analyze histopathological images. So these tissue samples are analyzed using XAI, and it will highlight the cell structure, which region contributed to cancer prediction, and what is that particular impact, or how did this contribute to this particular cancer. Say, even if there is an error, it will help you to diagnose the error, and also these are like evidence backed decision. It's like a smart microscope. It not only shows what is under the lens, but also shows like what is the impact of this, which part contributes to cancer, or which part is actually, which cell is actually the one that is causing these problems. So that is where XAI is adding the value to this particular solution. It is adding one more step. It's actually able to tell you which part and also which effect that it is going to have on that particular disease. So here is the pictorial representation of what we have discussed. So on the top part, we have without XAI, which is like a black box. And on the bottom part, we have with XAI. See, if we look at the top part, the model is predicting that the image is having, whether it have a COVID infection or not. The user does not understand the reasoning. So he is confused. Why is this person infected? Can I trust you? So the person is confused whether not to trust it or whether to take this decision, because there is no explanation that is given for that. So if we look at the middle row, it is actually the model highlights the specific areas in the image. It will highlight like which region is going to be infected and which is that reason or which region which contributed to this decision making process. So it is able to give a more trust in the user. It's able to actually give like a better trust to the person to believe that it is a COVID infected person. See, in the bottom one, it is actually a intrinsic XAI model. The model not only predicts the infection, but also provides like a proper reasoning, like for diagnosis. Which area resembled the infected patterns and why this particular decision, and every detail will actually be shown in the last part. So here you are getting a better trust. You know why this decision was actually contributing to this particular output and which feature contributed to this output. So that is where XAI is adding values. XAI can be like a post after the black box, you have an XAI, or it can also be like a intrinsic XAI model. It is not just in the medical sector. We have these kind of applications which actually need explainable AI solutions in different sector, say for autonomous driving cars. Here, the decisions need to be taken very quickly. You need to detect objects, you need to plan routes, you need to respond to traffic. Everything should be taken within seconds. How is AI going to act in such a case? Whether AI should tell the car to put a brake or do acceleration. So here proper reasoning is actually needed for every decision that a particular autonomous driving car takes. So it will have to take multiple things into consideration. Say, what is the markings on the road? Is there a traffic signal? Is there a pedestrian standing? And every consideration needs to be taken, and based on that it will come to a decision whether to apply a brake or to speed the car. So when we have an XAI solution, it will help you to give that reasoning why this car behaved like that. It will help you to actually increase the safety, increase the reliability, and also trust on this particular vehicle. So whether you should overtake, whether you should actually put a brake, whether you should actually wait for the pedestrian to cross. So all these are like critical things that need a proper explanation. So XAI is more like going to be a reasoning for the car. It is going to be like a car's brain. It is also going to explain why it took this decision, why this happened, what was the justification, and why this car took this decision. So, major companies are actually building explainable AI solutions, and XAI allows the developers also to give that trust to the public to also see like what is the logic behind every decision making. That transparency will help the public to gain the trust in autonomous vehicle and also to ensure the accountability of the system. So we also have other critical applications like surveillance system. So when we talk about surveillance, AI can actually detect people's movement. So AI can actually be used in airports, public spaces, cities for surveillance. But without explainable AI, it has a risk. You can actually lead to misidentification. You can wrongly identify one person as another person. So it should actually focus on so many different factors, and it should really give like explanation, like based on what features you identified this person. So when you add the explainable AI part, the error rate of confusing between two people can be reduced. It can also be acting like a security supervisor. XAI is like a security supervisor who actually audits an AI's behavior, making sure the system is not jumping to conclusion or focusing on wrong evidences. It will make sure the whole surveillance system is transparent, accountable, and trustworthy. See, because when it comes to very sensitive applications like as you identifying a person at airport, government facilities, government centers, military restricted places, it is very important not to wrongly identify. So that is where XAI is giving that added value. Then we also have XAI solutions in the retail and marketing sector to track a customer's movement, online patterns, and to know how to recommend them products, how these recommendations are made, to understand like why business is actually why the business can be affected by a particular customer reaction. So all this actually helps you to increase the revenue of your business also. When you clearly understand the customers needs, customers satisfaction, you're able to get that trust and satisfaction, it will actually reflect in a better profit in the business sector. So all these are like critical applications where XAI is very much important. But as this there is a need, there are also challenges that we face in explainable AI solution. The main challenge is technical complexity. So these models, which are like very complex, those have lots of parameter, it actually makes it more difficult for the end users to understand these technical insights. And there is actually a small trade-off between the performance. Explainable AI in certain models can actually have a conflict with performance. Some explainable AI techniques is actually may reduce the accuracy. It can be like creating a negative impact on the accuracy. So balancing explainable AI and performance is actually a very challenging task when we want to maintain that transparency, but at the same time we don't want to compromise the performance also. That is actually very challenging when we talk about XAI. And lack of standardization, there is no standard benchmark metrics for explainable AI. So it keeps changing, and you need actually a unified evaluation criteria to ensure the correctness and completeness of these explainable AI solutions or explainable AI explanations. So still it struggles to provide that consistency with respect to different situations and different context, and sometimes it is very complex. So these technical explanations provided by XAI may be like difficult for the normal end user to understand. So if there is a lack of technical expertise, it might be challenging to understand the explanations given by XAI. So you need to properly balance both complexity and interpretability. So that balance, to strike that balance is very important. So some models like decision tree, which are like simple, it is actually easily interpretable. But say if you have complex models, neural networks, they are actually like difficult to give that interpretability. And next is bias and fairness. So the algorithm may be trained on a data, so some that can be biased. Data can be biased, so the decisions it takes will also be biased. So this is actually a major problem that is faced. So we need to ensure the fairness. We need to ensure that the data these algorithms have used, it need not be biased, should not be biased. And finally, data privacy and security concern. All explainable AI systems will come to the data. It will actually depend on the data. So this can actually sometimes lead to privacy and security issues. So it's taking care of the data, safeguarding the data that is used for running and training is very important. And we need to follow all the individual's privacy rights, and it should be taken into consideration. So these are some of the challenges that we face when we start working with explainable AI solutions. And when we're working with explainable AI, there are few best practices to follow. So, one of the best practices form a cross functional committee. It can be having people from technical background, business background, legal, risk experts. So, they will have a clear set of standards. And we can define an AI framework with tools, documentations, review checkpoints, which can ensure that there is a transparency. So, in this whole system we build, we can ensure that there is a transparency. And we need to invest in talent and tools. We can build teams, we can train them in ethical AI practices, we can use XAI tools. So, the goal should be to make more explainable AI solutions, and so that training can be given off to the skills, or that skills can be given to the developers. Then choosing the correct XAI technique. So there are a lot of XAI technique, like I mentioned, SHAP or LIME or GradCam for computer vision based applications, or you can actually go with feature importance. You need to decide like what kind of explainable AI solution are you looking for. Do you want to know like a global explanation? How is the overall model working? Or are you looking at a very localized one? Why this prediction was made? So, once you get an understanding whether you are going for a global interpretation or local interpretation, based on that, you can choose your models. And also, we need to evaluate these XAI models. So, evaluation based on different criteria. It can be like based on accuracy, transparency, and also consistency. And we need to make sure all these explanations are stable and logical. With respect to the input that we provide, these should be actually logical explanations. So, an explainability is actually something which must have build that understanding, build that trust, and also something for you to act upon. So, whole idea of explainability is to make it more easy to relate to the output. And another best practice to follow is that we can ensure that the data is fair. The data is not biased. Data is not favoring any particular group or any particular set of people or anybody. The data is be biased. Continuous monitoring is actually a key for that. We need to monitor whether our model is drifting or even our data is drifting, because data can also change with respect to time. Similarly, model can also change with respect to time. So explainability isn't like a one time activity, it is actually a continuous responsibility. Whenever we work with an AI model or an AI solution, it's a continuous activity that needs to be taken care of to make sure this model is working in an ethical way. Now let's see like what are the different methods and toolkits. We can broadly classify it into two, that is model agnostic and model specific. See, first let's see what is model agnostic. Model agnostic means they are flexible and universal. They can be applied to different machine learning models no matter how it is built. They will analyze the input and the output and they will give the explanation. Not just on the internal structure of the model, the analysis is focused on the input and the output. So model agnostic works for different kinds of algorithm. And example SHAP, LIME. So these are like some of the model agnostic XAI tools or XAI frameworks that can be used. This is more like a general purpose one. It is ideal for multiple models. And if you are like using it for consistent explanation approach, this model agnostic is one thing that you can use. So model specific means these are methods very specific to certain architectures or certain models. Say, for example, neural networks or decision trees. They will work based on the model's internal working. They will work based on how the model is working internally and what is the internal layer by layer structure or rule that is it is using. It will come to this particular output. So, for example, for model specific is GradCam. So, gradient cam, that's GradCam, which can be actually helping in visualizing which features contributed to this particular prediction. So, it's like a more visual kind of explanation. So, to keep it simple, model agnostic is more general and flexible. Model specific is like a detailed and targeted one. It's a model specific one. Now let's see in detail one model agnostic method. So when we talk about model agnostic, we can see like the example of SHAP. So when it is SHAP, SHAP is actually shapely additive explanations. Like I mentioned earlier, this is actually used to know about which feature contributed to this particular output. Say, for example, this whole idea of SHAP works on game theory. How to fairly divide rewards among players when there are multiple players in a game. How can you fairly divide that prize money among the players based on their contribution? So that was a game theory which is actually used in this particular thing, that is a SHAP. So, how much is a feature's contribution? Whether it's a positive contribution or whether it is a negative contribution, we can understand using the SHAB, and we can see like what is the individual impact of each of these features, how these features will affect the decision making process. So, how was the influence is something that we try to understand with the help of a SHAP, whether it's a positive impact or a negative impact. Say, for example, loan prediction itself. Say whether your credit score is going to influence it positively or whether your credit score is going to influence it negatively. So using SHAP, we can actually calculate values. And these are values like how we get it for the game theory, how to fairly divide the credit and contribution. So we will find this Shapley values, and this values is like a very clear and quantitative view of how important each feature is, how it will actually contribute to a particular prediction, or how much is the contribution of a particular player in this particular game. That analysis we can get from the SHAP values. So one of the biggest advantages, it can be applied to so many models. So it does not depend upon the model's internal logic. It actually works like based on the input output. It is a model agnostic method. It is consistent and will provide comparable insights. So whether the model changes, it does not change the insights. It will provide comparable and consistent insights regardless of the model type. SHAP is also something which can be applied for both regression and classification problems. So you can understand like the feature significance using SHAP for both regression and a classification problem. So let's see like with an example how we can understand this. So if you look at this image, we can see like the MNIST data set. This is the numbers data set. You have digits, handwritten digits from 0 to 9. Let's imagine that we have trained an AI model to recognize these digits. So most of the predictions will be like correct, and but sometimes it can have a chance to confuse between 3 and 8 or 9 and 4. There are situations misclassification can occur. To understand like how this error is occurring, SHARP can actually help you highlight like what is the contribution, what is a positive influence or what is a negative influence. And to show that visually, it uses two color gradations. Say it can show it with the help of a red color and a blue color. So if you look at this particular image, the actual digit is 1. and the model is correctly predicting it as 1 with actually a high confidence of 99.65. So the SHAP visualization highlights the areas which have like that influence. So in the image, so that the red region represents the positive contribution. So the red region is actually contributing to identifying it as 1. And the blue region indicates like the reduced confidence, which is where the confusion is occurring. So here we have two color codes to show the influence of the regions. So red is going to contribute the positive and blue is showing like a confusion or the reduced confidence in prediction. So let's see one more example. So here it is with respect to the digit 8. The actual label is 8. The model is predicting 8 with an accuracy of 99.54. So when you look, the red region in that image actually supports the classification of 8. In the case in when we look at this 99.54 particular example, the red region is around the top and bottom loops. It very clearly shows that it is like a two circular structure, and that is where it is able to identify it is a number 8. So that is actually what is contributing to this classification, that the correct classification that this is actually 8. So when you think of SHAP, it can be like a X-ray. This particular thing, you can actually compare it to an X-ray where you are trying to know like what is inside, how it came to this conclusion, where is this attention drawn, and what is contributing to take that decision. It is a number 8. So if you look at this particular image, you can see like both accurate and also inaccurate classification. In the accurate model, the sharp visualizations show red regions which are tightly focused. And for example, if we look at the number 3, the sharp highlights the two curves. When we look at 8, it highlights the loops, two loops. So that is how it comes to a conclusion. It is a number 3, and based on the loops, it comes to a conclusion. It is the number 8 that is listed there. So this pattern is actually what it helps us to come to that understanding or decision, which is the number. Where to pay this attention? What is that meaningful feature that is contributing to this particular output? So SHAP gives you very clear and localized explanation, very clear logical reasoning why it came to this particular output. So you can very clearly understand like which instances went wrong also. So this can actually be based on so many factors. See, based on background noise, based on random strokes, it can actually even due to a model overfitting. You are training a model too much or model is overfit. So all these can also be reasons why it comes up with a incorrect prediction. So when we use a SHAP, it will actually shows it like regions which are actually contributing to that particular output. Now let's see one more example, and this is with respect to model specific method. So when we talk about model specific, we will see like how GradCam works. So GradCam actually help us to see which part of an image is actually taken that focus when it is giving a prediction. See, we know CNN or convolutional neural networks is used to predict whether this what image it is. Say when we are looking at this image, we actually need to say whether it's a lion or a dog or it's a car. But what is contributing to that prediction? How is it going to say this is actually like a line? So if you look at that image, it will actually, when we do a GradCam, the result is actually a heat map. So in that heat map, the most influential, so whatever regions which contributed to the output, the most influential region is actually shown in red and yellow. So those regions actually contributes the output. The blue region have no influence at all. So if this particular example, it is the lion's face and the main, which is actually going to give that prediction, it's a line. Those regions which have that complete contribution is basically its phase. So the heat map has highlighted the legs. Heat map has shown us the mainly the phase. So there are also like situations where it can get confused also. It may not like give like a proper explanation. So we have like advanced models. We actually get a visual explanation about the model's reasoning here. So it is also helping us to understand like how the model came to this understanding this is a line. See here in this particular image, if we look, there are two animals. One is a cat and one is a dog. So when we pass this image to a convolutional neural network, it will actually have to say which is a cat and which is a dog. And this CNN is actually trained on two categories, that is cat and dog. So how is it going to tell like which is a cat and which is a dog? This is where GradCam comes into picture. It can help you visualize where in this image it looked to take this decision. It will generate a heat map and what is the part which had the strongest influence on the output, or why it said it is a dog, or why it said it is a cat. Say, if you look at these images that are shown there, the first image is the original image, and the second one is like which is giving us a prediction it is a cat. And why it classified as a cat is based on those regions which are highlighted in red and yellow. And in the second part, if you look, the dog one, it is basically highlighting the dog's face, ears, and upper body. But when it was for the cat, it was actually focusing on the overall shape, the cat's fur, everything to come to a prediction. It was a cat. So there are like different features that are considered for both of these images. So for one, if it was the fur and the overall body, for the dog, it is actually the face, ears, and the upper body that is contributing to this prediction. So this kind of visualizations help us to confirm that where each class is specific. So since this particular image have multiple classes, each class specific prediction is grounded in this relevant image regions and it's not based on random noises. So we have seen like what is GradCam, and the advanced version of GradCam is that is actually GradCam Plus Plus, which can also be adapted for vision transformers. So when you want to know about like how vision transformers can be used for analysis, we actually have the GradCam. So GradCam Plus Plus actually highlights the importance of regions in an image more precisely. This is usually used when you have multiple objects in the image or when the objects are very small or partially visible. So if you look at the example, you can see there are multiple dogs in the image and there are multiple things in the background. So you can see how is the difference with respect to GradCam and GradCam Plus Plus. So these are like two versions itself. One is like an improved version of GradCam and how the CNN is coming to this particular explanation. Say in the first one with multiple dogs, how is it happening? And like where all these images, you can see like the difference it is shown in respect to GradCam and GradCam Plus Plus. So this is like a more influential one when it comes to a model's prediction. What is contributing to a model to come to this prediction? So on an overall, explainable AI is actually going to give you like an understanding, like what is contributing to this particular decision, what features, say if it is with respect to images, which region is contributing to this particular output, say if it's with respect to data, which features is contributing to that particular prediction, whether a person should be given a loan or not, which features contributed to the decision. So that kind of understanding is what makes the model more trustworthy and transparent. So explainable AI is actually used to add value to the AI solutions and also build that transparency and accountability aspect to AI solutions. So, with that, we come to the end of today's session. Thank you all for attending today's session. Before we wrap up, a quick reminder about the next session. So, next session is on October 15th, 4 to 5 p.m., and that is on how we can use generative AI for coding and automation. So I expect that you will all register for the October 15th session. So please visit the website and register for the upcoming session. And I request everyone to complete this quiz, and the quiz is already uploaded in the portal. You can just visit the website and you can get access to the quiz. So every participant needs to minimum do a 3 sessions quiz and attempt that self-assessment quiz to be eligible for the co-branded certificates. So if you have any questions or queries on today's session, please feel free to type it in the chat. So if you want to go to get access to the previous sessions, you can actually go to the link where you have registered for these sessions. And when you click on the resources, so there is actually an option known as view resources. You can just click on the view resources, and there you will get access to all the recorded sessions of the previous sessions that you have registered, and you can see the YouTube videos of the previous sessions there. So the quiz is currently uploaded, and you can just go to the link and attempt the quiz.